Closing out today, we've got Neil and Phil, who are going to be doing network monitoring and analysis, we hope.
We've been left with very little time, so unfortunately we can't do the full.
Really big network to monitor, it doesn't work well.
No, it's one way through the island, and sorry, I did say.
Just because it's JavaScript, I really sort of have to think about it easily. IBM. Look what he got. It did look, I loved the interface. Even down to the fashion curvy line.
Can everyone hear me at the back? I'm not going to use the headset because I look like Janet Jackson, as it's just been pointed out. Right, we were going to do a demo on monitoring and analysing network performance. We're not going to do a demo, but in the best Blue Piece of fashion, we've got one that we prepared earlier on some live data. We're going to need to plug this thing into the thingy. The concept is we're both network geeks, and one of the things we quite often have to do is to monitor the performance, throughput, and latency, and jitter, and so on across a network. Now that network can be a local area network over Ethernet. It can be a cellular network over like your mobile phone uses. It can be a wireless Ethernet network, any form of network. And one of the terms that you'll see used an awful lot these days in marketing speak is the cloud. Hopefully we're going to have a picture of a cloud in a minute with some Raspberry Pis connected to it. Anyway, we're going to show you a picture of a cloud. Now, to measure performance across any network, it's not a new science. There are many ways to do it. We've been doing this for years. The problem is that a lot of those methods are actually quite expensive. They rely on dedicated controllers, dedicated hardware, and some quite expensive, powerful equipment. We're both tight, and we come from Cambridge, so we thought that Raspberry Pi might be a good platform to build something purely using open source tools. So we're keeping the cost down to an absolute minimum. The concept is that you have a script running on one Pi that can send traffic to another Pi in a network, and then we've got control channels back to a server which just collates data into a database. And then the Pi's just running GNU plots, so more open source software, can take that information and produce some nice graphs to show network throughput and latency and jitter and any other metrics that you really care to look at. The only tools that we're using, as I mentioned, GNU plot. We're also using another tool called MTR on the Pi, which again is freely available in standard distribution, and it's just kind of a fancy ping, effectively. I'm really hoping this picture's going to come up here quite soon. That's it.
No, Joy. Sorry.
Right, okay. We have no pictures.
Top my laptop above my head. It's this one.
Sorry, I'll draw some pictures of traffic going across the canal. Which port were we using for the presentation just now? Were we using this one or that one?
Oh, has the projector shut down?
Every techie has an idea.
Right. So what we have here is a cloud. We had to have a cloud. Now, as we say there, that can be any form of network. In the demo that we were going to run here, it was just using a small Wi-Fi network. The data that we're going to show in a minute is quite a major carrier's cellular network. The limitation is the speed of these links here and here, because the Pi only has fast Ethernet ports, so you can't really measure any throughput where you think it's going to go above about 80 meg or so. I mean, in theory it'd be 100 meg, but because the Pi is doing a lot of other things on the same bus as the Ethernet port, it won't run at the full 100 meg. That's one of the reasons why I mentioned earlier you have specific test equipment from companies like Fluke and Nixia. The difficulty there is that we priced this up, and using a commercially available system, the probes that go there and there are $1,200
each.
And the server there to collect the results was $10,000, and there's $1,000 a year to license the software. We've done the same thing for 60 quid and an old laptop, which maybe we thought was a bit of a bargain. And this is, as Phil's going to show in a minute, this has been proven to work in a commercial environment. The other nice thing is that because these Raspberry Pis, they're only small form factor, they're easy to plug an SD card in, you can ship them around the world to install in a data center somewhere, just leave it running and run a cron job every week, every 2 weeks. So you come into your desk on a Monday morning and you have a pile of graphs telling you how busy your network was over the weekend. With that, I'm going to hand over to my glamorous assistant to go through some real life data.
Yeah, cool. So just before I do that, I might make it easier for me to see the work from this laptop. Just bear with me. Hopefully this will work. We've blanked out the screen. Blanked out the screen?
Yeah.
Gutted. Okay. So at least we know what the problem was. Right, I have to break my back then. Okay, so yeah, let's find some. So as Neil said, our use case was right. So yeah, hey, network geek, right? Had the responsibility to select some cellular carriers to use around the world to hook up to our rather global backbone. And before we wanted to do that, we wanted to measure and test how well these cellular providers were functioning. So yeah, we shipped out a bunch of Raspberry Pis and laptops and all sorts. And as you can see on the diagram, the idea is, you use a set of scripts from a central server. Ours was in Germany, to drive these remote nodes, and there's nothing really complex going on here. We haven't coded anything. I'm no coder. We use shell script, so the control traffic goes through SSH out to the remote device. It runs the tools that Neil was talking about, IPO, NTR. Really, the complexity is just in about writing a shell script that cycles through these tests at the right bandwidth levels and the right frequency for you to generate some results. So for our particular test of a cellular carrier, the idea was make these scripts run for 7 days, absolutely hammer the hell out of a cellular provider's network and see what it would do. I can equally think of scheduling that test to be, well, let's run at midnight every night on the end of a Wi-Fi network, so when I get into work the next morning, because I'm Mr. Administrator of a whole bunch of different wireless APs, I know that my wireless networks are still functioning. You know, you could schedule pings to run, etc., to really monitor. So, but let's have some. Well, look, throughput is what everybody understands about networks first of all, right? So, and I think this is a lovely graph to show about cellular networks. Right? Everybody understands what throughput is, right? As in the bandwidth in your network. So on the left-hand side, we've got the kilobits per second of the cellular provider. Across the bottom, we've got the time. So this was 5 days, not 7 days. And then the coloured lines each represent a specific rate of bandwidth that we tried to test downstream through this cellular provider's network. So I had a Raspberry Pi connected up to a router with a SIM in it in the centre of Cambridge, testing this particular cellular carrier's network. The 24th of January was a Friday. So on Friday and Saturday, we're not quite getting as good a network performance as we would on a Sunday, Monday and Tuesday. Why is that? Everybody used their mobile phones on Fridays and Saturdays. So this is really good information for us as networking people when we have to provide service to a customer to say, particularly if they're coming from an arena where they're used to DSL and Ethernet and reliable network performance, and they're now switching to cellular services, to say, well, look, don't expect things to work as well as they might, you know, during the day as they would overnight. I mean, there's many data points there. As I said, there's nothing clever about what we're doing necessarily with the tools. They're stock Linux tools. It's just in the scheduling in terms of cycling through these bandwidths. So very easy to write loops in shell script to cycle through certain bandwidth values and run a bandwidth test at that speed, and for it to just cycle through for a number of hours until the test is finished.
We have a question.
Are you not at risk of taking out the last few drops of bandwidth by, if you're going to do it in the middle of the day?
You are correct to say that the testing is network impacting, yes.
So yeah.
I presume you do it for like almost instantaneous bursts for a very short period, and then...
The particular test we run on these cellular networks, and bear in mind that if you are using this on your home bandwidth, for example, you will be charged for the data that you have. Being a nice big carrier, we twist the arm of these cellular carriers and say, can you give us a test SIM free for a week and not charge us for any data on it? Job done. So we would run each test for a full minute at the level of bandwidth that is on the legend. So yes, we eat gigs and gigs and gigs worth of data off their network during this test, and they don't necessarily like us for it, but ultimately they want to sell thousands of SIMs into this whole Internet of Things thing, right? This is absolutely related to this. Internet of Things in a lot of people's minds almost equates to using cellular networks for connectivity. Yeah, they want to sell thousands of SIMs into as backup for retail sites.
Do they not already know the throughput of their network?
You would have thought so, wouldn't you? Yes, they do. I mean, they've engineered it. We're just testing it, and if we can go to their engineers and go, you said X, but we're not getting anything like that. That gives them something to go and look at.
It's about putting the data into your hands rather than theirs. And also, they've probably designed their network to work for home users. You know, sending SMSs, making phone calls, browsing little bits of data, not for necessarily acting as the connectivity for a whole retail shop doing all their credit card transactions. Very different, use case for their.
It's also this is also time of day. Number of users sensitive.
You'll say
if they're building it for a certain
because
speed
if you look there where we're getting very high throughput, that is in the middle of Sunday night. Everyone's asleep. If you look at the same time on Saturday, well, it's not getting anywhere near the same throughput because 3 o'clock in the morning on Saturday, well, everyone's in a club tweeting their mates.
Yeah.
So this setup, so you've got like a GSM modem, your Pi at one end, and then at the other end you've got. Is it in the cell phone provider's equipment rack, or is it?
In this instance, yes. in this instance,
in this instance, let's say location 1 was a server in Germany.
Right.
And location 2 was a router with a Pi on the back of it, the router with a SIM in it, sat in a house in Cambridge.
Right, okay. Yeah.
So you're really simulating a user's experience.
Yeah.
Yeah, absolutely, that was what I did.
A heavy user, not heavy, but
I mean, one thing
Man, you've not seen my tabs on my browser.
I mean, one thing that intrigues me about this is, I mean, it's great for cellular networks where you're talking about 4 megs or stuff like that. But as soon as you try and go more than that, like you said, the Raspberry Pi's network interface is not very good. It's basically a USB network dongle.
Absolutely.
I mean, have you thought about maybe using something a bit like a BeagleBone Black or something like that that's perhaps got a bit more of a
The
better...
reason to choose, say, shell script and dot stock Linux tools was theoretically exactly what I've written now on, because remember the scripts are really stored on the server, and you only are making sure that the tools that you're using are installed on the Raspberry Pi. Instead of sticking a Raspberry Pi out there, I could have put a big fat server out there with a quad-core processor in it to generate a gig's worth of traffic.
So basically, your SSH into the Pi.
Absolutely.
That's very simple.
We've got
Very simple, but aren't all the best ideas simple at their core, right? And like I said, we're not a team of coders, we're a team of network geeks, so it needs to be something...
So basically, if you wanted to upgrade, you just swap the Raspberry Pi for something else and make sure the tools are installed and the job's done. That's a good solution, yeah. But like you said, the Raspberry Pi's got the advantage that it's small, you can stick it in someone's rack.
Precisely, our use case was testing LTE, so even somewhere really, really good for LTE like Korea, 20 megabits per second is about as high as it's going to get, and you've got to ship the device out there, so why am I going to ship a laptop or a server? I'm going to ship a tiny little
That's still faster than your 20 meg, isn't it?
Yeah. I'd also say you can just, if it comes to it, you can just ship a SD card.
Out of interest, what did you say you were getting the max out of the Pi? Was about 80 meg, you
It
said?
depends on the size of the packet, because it's about generating a number of packets. So if you generate a large packet, 1500 byte packet, 80 meg. An enterprise style packet, which is really what we measure for our typical customer, it's going to be lower, it'll be about 40 to 60. And a small packet to represent voice, or VoIP, I should say, 52 bytes, you're only going to get up to 10 megabytes. But that's okay, because VoIP traffic is very much a tiny proportion of usage on the server. So we only test that at 10% anyway.
That's important because it needs good latency.
Yeah, so I was just going to say, the other point about this was really, then let's have a look at jitter.
Do you set any QoS bits in your packets?
I haven't got the script here, but we do then have another test that we run, which is a packet monitor on one end. You start a packet monitor on one end, I haven't got the diagram up, packet monitor on one end, ping generator on the other. The ping cycles through every DSCP bit that we expect to be carried as transparent through the network. The monitor counts them up at the other end. So if I send 5 of every DSCP bit at this end and I get 5 of every DSCP bit arriving at the other end, great. Because we have had carriers who would rewrite those halfway through the network.
Yeah.
And so you send 5 of everything on one end, you get 105 of best effort at the other instead of a range of markings. So.
Yeah.
But I mean, the interesting thing is, jitter very good, even on the cellular network, for VoIP. So, viable as a VoIP service. And actually,
the cellular providers won't thank us for saying that because, of course, they don't want you to use that.
That's an LTE network.
That's right.
Not a.
That's LTE, correct.
No, this is 3G.
Is it?
HSPA. I should say properly if we're calling it technology instead of marketing to them.
A 1 millisecond jitter.
That is quite impressive for a radio network, isn't it?
Yeah.
Between Cambridge and Germany.
And yet I still can't get Google up on my phone.
Remember, this is okay. So let's be straight that everybody understands what jitter is. This isn't the latency between the two endpoints. This is the variation in latency between the two endpoints.
Yes,
so
network latency graph.
we will have latency
Jitter
graph.
actually is
So-
if you have a VoIP call going and it sounds a bit.
I'm sure you've spoken on Skype, right? Then you sort of start talking like that. That's because the packets are arriving in an infrequent timescale. But latency, which I guess is more
if
what
you
you're
got one for
thinking
latency,
of.
that'd be.
Is what we read earlier.
True.
Here's an interesting one actually, because you can see hop 1, we're basically doing a trace through. So all different hops. So hop 1 to hop 5 are all wired. And you can see right down in there, almost unmeasurable. First radio hop to hop 6 is where all of the latency is. And then hop 6 to hop 7 is again, that's wired in the carrier.
Because I mean, okay, 600 milliseconds, that is going to make a mess of VoIP, isn't it? Well, it's going to be like talking to your nan in Australia back in the day.
I wouldn't run, something like a Citrix trial or something, but then, we're not, that's not what we're measuring.
It's already Citrix.
No. So I don't think we're not exposing anything surprising here. I mean, okay, so all the previous graphs up to this one have been generated out of iPerf, so that's the bandwidth measurement, and then this is the graph that's generated by MTR as the tool, which sort of pings every
Are you, out of interest, are you open sourcing any of what you've done, or partnership?
I honestly
Are you
don't
making
know,
a business
because I mean, no, genuinely, the scripts have been written in our spare time to solve a problem that we had in our working lives, and we haven't given any thought to reuse by anyone else.
Stick it up wall
So,
It's something
But, I mean,
clinical network, you people here, stick it up wall.
I mean, I think the argument is, could we not open source it, given that all the code that we've used are open tools already, and all we've done is wrap a shell script around it? We haven't done anything really.
It's just shell scripting. All of the logic behind this is just automation through shell scripting.
There's no solution.
There's no invention really. It's all the tools are already there. Somebody else built the pie. Somebody made GNU plot. Somebody made iPerf.
So it's more blog post than a product.
Yeah, exactly. Yeah, we just want something together to automate somebody sitting there pressing buttons.
Screaming out for LEDs. Green, orange, red.
At this point, I'm going to have to run because I have a dinner date, so I'll leave
Yeah, so I will take questions.
Thank you, Jax.
Yeah, so as I said, I'll use thanks, Neil. So our use case for cellular, I can imagine that you could use it for monitoring Wi-Fi, probably overnight, right? So you're not impacting the users. But I guess if you've got a call during the day, it'd start something up. I mean, nothing stops you leaving a Pi screw to the wall with a Wi-Fi adapter in. Is there an instant monitoring tool? There are other things that we haven't coded in yet, like actually doing monitoring. Who's to say you couldn't write a shell script or a cron job to go around and make these things ping between each other on a frequent basis and ping you up, like you said, a green or red result on a website. So, I think ultimately it comes down to there's a lot of power in Linux and the existing tools out there today if you just tie them together in the right way. Any other questions? Okay, let's leave it there then.